Okay, so now we've defined all these trig functions. And we've done the calculations with them. It's time to start applying them to the right triangle a little more and using them for something a little more usable or applicable. So in practice, so let's say we have a right triangle. Now, if you look at this, you might think, well, we don't know anything about it. Well, triangles have 6 pieces. Well, 3 of those pieces are angles to your sides. If we know 3 pieces of a triangle, 3 out of those 6 pieces, and one of the qualifications is at least one of them has to be a side. Doesn't necessarily have to have an angle, but at least one of those 3 pieces has to be a side. We can find everything else. Well, in this case, like I said, you look at it, you may think we don't have any information about it. Right now, we do have one of those 6 pieces. Can you tell me what it is? 90-degree angle. We have an angle. So we need at least one of the sides. So let's say that I tell you that this up here is 37 inches. And this down here is 29 degrees. From here, what's that? You want to find the sides now from here. Got X and Y. This angle up here is probably the easiest thing to find. How much is it? 61. 61 degrees. How'd we get that, by the way? Yeah, we got that up to 90. So 90 minus 29 makes 61. So how do we find X or Y? Well, I'm going to use the 29. So we're going to use the 29-degree angle because we know that's right. It was given to us. Now, well, pretty hard to screw up 61 degrees, but we did calculate it. And there's always that small chance we screwed something up. So we're going to go back to the 29-degree angle because it was given to us, and if that's wrong, it's somebody else's fault, not ours. Let's find X first. According to the 29 degrees, we have the 37 inches. What side is that? Hypotenuse. That doesn't depend on the angle. It's always the hypotenuse. What side is the X going to be? Adjacent, which is which trig function? Cosine. Cosine of an angle is adjacent to hypotenuse. I always start out by writing out the trig function. At least for you guys at this beginning stage, it's really, really helpful to do it. Now I can just fill in my information. Do I know the angle? 29 degrees. Do I know the adjacent side? No, that's X. That's what I'm looking for. Do I know the hypotenuse? Better, because I already have one unknown. So to solve this, the easiest way to do it is to make it a proportion. Just like this. Put it over 1. So I have now cosine of 29 degrees times 37 divided by 1. Cosine 29 times 37. Yep, 29 cosine of 29 times 37 and divided by 1. 32.36. So that's telling me is that X here is approximately 32.36 degrees. Now there's 2 ways I can go about finding Y here. I'm going to use the trig method, but I could use a squared plus b squared equals c squared if I wanted to. Trigonometry-wise, Y is which side here? Well, we got to know which angle we're using. We're going to stick with the 29, so Y is the opposite. What trig function uses opposite hypotenuse? Sine. Now some might ask, well, couldn't I have done this side and use tangent? Sure you could have, but remember, this side length, that's inches, not degrees. This side length is one we calculated, and again, there's a chance we screwed it up. Whenever I can, you go back to information that was given to you because it's less chance that there's an error in it. So now filling in, I know the angle is 29. The opposite side, that's Y, that's what we're looking for. Hypotenuse is 37. Put that over 1, so it'll be sine of 29 times 37. So So sine 29 close parentheses times 37 divided by 1, of course, doesn't change anything. 17.94. So this is 17.94 inches. That's not so bad, right? Better than sharp stick in the eye? Cool. What's that?
Better than bat insulation.
Yeah, bats fly south. They don't get to steal one.
No insulation. It's so itchy. Wear a sweatshirt, though. What? Think I'm gonna wear
So what happens if, instead of having an angle, in a right triangle, if we have one of the angles, we have the other one, because we know what they have to add up to. But what if we, instead of having one of the angles, we still got one piece, we still have one angle with the 90 degrees, but instead of having a second angle, let's say we just have two sides, like, oh, this is 12 feet and this is 5 feet. Well, we can always find the third side here, if I want to call that x, by a squared plus b squared equals c squared. We'll put an x squared at this point. If you figured that out, x is going to be 13 feet. I'm going to trust you guys can handle that one. Now I need to find one of the angles. I'm going to call this angle A here. I could use the 13. That would allow me to use sine or cosine, but I don't want to because we calculated that, and I don't trust us not to have screwed it up. So we want to use what was given, the 5 and the 12, which are both legs, which means we're using tangent. Tangent of an angle is opposite leg over adjacent leg. And now which one of these is the opposite leg? 5. So this is the adjacent. We don't know the angle, so this is going to be, the variable A is going to be put in for the angle. Opposite is 5, adjacent is 12. So now, before, what we've done when we're looking for a missing side, we've always made it a proportion and cross-multiplied and divided. We don't do that here. Since we're looking for the angle, we do an inverse tangent of 5 divided by 12. Giving us 22.62 degrees. Yeah. Or you could do the 5 divided by 12 first, but you get like 0.4, blah, 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 blah. And then you got to try to write it down, but it's going to be rounded off that way. Got her? Of course, now the other angle up here is going to be pretty simple to find. It's just going to be 67.3 degrees. So in this one, I want you to find angle A down here for me. I know you can find the side up there, so let's just find angle A is what I want. So we got 26.56 degrees. Anybody have questions? Well, because my voice hurts, I got to get through an ITV lecture. Page 734, exercise 34-3. And page 737 through 738. Exercise. Good one. 34-4.